This video is on slope. That's our topic for today, and you'll see at the top a box that has the slope formula. It says the slope of the line through the distinct points x1, y1 and x2, y2 is given by, first off, m represents slope, and we call it rise over run. The rise being the up and down direction, so how much the y changes, divided by the run, which is the left-right direction, or how much the x changes. And if you write that as a change formula, it's y2 minus y1 over x2 minus x1. It says here that x1 cannot equal x2. The reason being, if it did, you would have a 0 in the denominator. So if you look at the little example here, and we use the definition rise over run, it means to get from this point on my line to another point on my line, how much do I have to travel up or down, and then right or left. In this case, it was up and right. Now, if I wanted to go from this point all the way down to this point, my travel would be down and then left. So that's the definition of rise over run and what that means. So when we are finding slope, we're going to look at a couple different ways depending on what you're given. So here we're going to be using the slope formula if we're given 2 points. So you're given the point 2, -1 and -5, 3, and we want to know the slope. Your first step is to label x1, y1, x2, y2. And then the next step is to just plug in to our formula. I changed that light, it was a little bright. So let's take a look. The formula is y2 minus y1 over x2 minus x1. That would give me y2 is 3, take away y1 is -1, be careful with signs, over x2 is -5, take away x1 is 2. In the numerator, that gives me a 4 over a -7. So my slope, another way to say that, is -4/7. Now let's look at y. We're going to do that on just this first one. So if I plot my points, the point 2, -1, and the point -5, 1, 2, 3, and then I use a ruler to connect those points to make the graph line. And then we're going to just count and see why it actually is -4/7. So if I start at this point and I want to travel down to this one, I would first have to go down 1, 2, 3, 4. So that would be down 4. And then to get to the other point, I would have to go right 1, 2, 3, 4, 5, 6, 7. So right 7. Down is a -4, right 7 is a +7, and I get -4/7. Yes, I realize the negative is in the numerator here, and here it was in the denominator. Doesn't matter, it's still a negative fraction. With a different color, let's travel from this bottom point here up to this point, and you will see it doesn't matter. It's still going to be 4/7 negative. So to travel, we would go up 1, 2, 3, 4. So this time I went up 4, and then I would go left 1, 2, 3, 4, 5, 6, 7. Left 7. Up is a +4, left is a -7, and I still end up with -4/7. It doesn't matter which way you travel. Just remember that it's not like locating points where you go left or right first. This is slope and the relationship of the rise to the run. So you go up or down and then left or right. Let's look at the second example, which says rearranging the equation to find the slope. So we're going to use this equation y equals mx plus b, which is a very common equation in math. And when an equation is in that form, y equals mx plus b, the m is always the slope, so it's the coefficient of the x, and the b is always the y-intercept, or the point 0b. So if I want to know the slope of this line without making an xy table and finding 2 points, then what I need to do is I need to rearrange that equation to get it into y equals mx plus b form. So I'm going to do that by subtracting an x from both sides. Negative y equals, I'm going to write my x term first because we know that that's how we want our equation to look. Now I have to divide by -1. You can't leave it a negative y. And we get y equals negative divided by negative is a positive. Negative divided by negative is a positive. And in that form, I can just look right here and see that my slope is 4. I didn't have to find 2 points. So that's very, very handy. Let's try another one of those where we rearrange the equation. So we're going to subtract a 3x, negative 5y equals negative 3x plus 8. Now we're going to divide each term by negative 5, and that will give me, I'm going to write it over here because I'm kind of running out of space. That will give me y equals a negative divided by a negative is a positive 3/5 x. A positive divided by a negative is a negative 8/5. And again, I can read my slope right here as the coefficient on x. My slope is 3/5. All right, let's take a look at slope in some special cases, meaning horizontal and vertical lines. So if we look at example 4, it says find the slope using one of the ways discussed above and graph. So we're given this equation y equals 2. Now if you remember that that's a horizontal line, that's great. You can go ahead and graph it. But if you don't, you're going to do your xy table. Y has to be 2, so I'm going to put that down twice. I'm going to pick anything I want for x, it doesn't matter. And when I graph it, I have the point 0, 2 right there. Oops, I graphed too soon. And the point 2, 2. The graph is still correct. So let's use those 2 points, 0, 2, and 2, 2. We will label x1, y1, x2, y2, and we'll use our formula. y2 minus y1 over x2 minus x1. Or 2 minus 2 over 2 minus 0, which is 0 over 2, which is equal to 0. So the slope of this horizontal line is 0. And we can go so far as to say the slope of horizontal lines always have, the slope of a horizontal line is always 0. All right, let's look at the next one. Given the points negative 5, 7, so I've got negative 5, 7, that's right here, and the point negative 5, 1. If I connect those, you will see that that is a vertical line, and we want to know what is the slope of that vertical line. So I'm going to label x1, y1, x2, y2, and I'm going to fill in my formula. M equals y2 minus y1 over x2, take away x1. That gives me a negative 6 over a 0. And I hope you remember that division by 0 is undefined. So the slope of this vertical line, which is what we have, is undefined. That's different than 0. So let's kind of do these conclusions that you'll see there in the middle of your page. The slope of a horizontal line will always be m equals 0. And I want to show you something. Look at the word horizontal. Starts with a z like 0, has zeros in it. So you can kind of go horizontal and 0 go together. The slope of a vertical line is undefined. Always, no exceptions. All right, example 5, we're going to graph the line using whatever we're given and what we know about slope and points. So the first example in 5a, we're given the intercept of 0, -4. So 0, -4. So I'm going to plot the point. That's what I did first, is to plot that point. And then I have my slope is 2/3. So let's think about what that means. It's rise over run, and since they're both positive, that has to mean up 2 and right 3. So from this point, I'm going to count up 2, right 1, 2, 3. That gives me a second point. I connect them, and I have graphed my line. So I first plot the point, and second, I count the slope, count rise over run. Let's try another one. In example B, we're given the point 3, 1. All right, so 3, 1. So once again, I'm going to plot the point. That's the first thing I do. Even though it's not the intercept, it doesn't matter. It's still a point on my graph. And then I have the slope of -4. I'm going to put that over 1. And I know that what that means is, it means, since it's -4, down 4, +1, right 1. That's why I put the 1 there, so you would remember to go right. So from this point, we're going to go down 1, 2, 3, 4, right 1, which is right here. And when I connect, that's kind of crooked. I should be using my ruler. We have graphed our line. Again, by plotting the point and then count the slope as rise over run. Okay, let's look at our last two. On this one, I'm given the equation y equals 3x minus 3. Now you've got to remember that equation, since it says y equals, it's in slope-intercept form. So I know two things about that equation. I know that the slope is 3. Right there is my slope, or 3/1. And I also know that my y-intercept is the point 0, -6. So now I'm back to an example like 5a, where what I'm going to do is, 1, I'm going to plot the point, and 2, I'm going to count the slope. So let's plot the point 0, -6, which is right here. And now that +3/1 means up 3, right 1. So we're going to go up 1, 2, 3, right 1. There is my second point, and I connect them, and I have graphed my equation. Finally, in example D, we're given the equation 4x plus 3y equals 6. Now there's two different ways you could do it. You could do an XY table here and find 2 points. I don't want to do that because I'm going to get fractions. So what I'm going to do instead is I'm going to get that equation in y equals mx plus b form, and then I'm going to use the m and the b that I will see from that rearrangement. So we're going to subtract a 4x. That gives us 3y equals -4x plus 6. I divide each term by 3, and you get y equals -4/3 x plus 6 divided by 3 is 2. Now again, because this equation is in y equals mx plus b form, it tells me two things. It says the slope is -4/3, or down 4, right 3. And it tells me that the y-intercept is the point 0, +2. That's what this tells me, 0, 2. So I'm going to plot my point, 0, 2, right there, and I'm going to count my slope, down 4, right 3. down 1, 2, 3, 4, right 1, 2, 3, and I have it. If I could draw this straight without a ruler, oh, that wasn't too bad. So we've used whatever information we were given to graph our line.